Hello, and forgive me if I'm wrong. Speaking Lithuania. Is that correct? Yeah, great. So I've been told that you can write all the questions that you have to the Slido. You might have the link. If you don't know the link, you have the link behind your badge. So you can use that and write the questions. And if you have any important question that you need to know answer right now, you can just raise your hands and ask me. Great. Let's go into the talk. Easy microservices in the cloud with Kubernetes and Istio. Just before that, how many of you guys are doing microservices? I know there are a lot of talks in microservices. Okay, quite a few. Kubernetes. Few. Istio. 1, 2. Okay, that's expected. Great. And a little bit about me. I'm Sendil Kumar. You can reach me at this handle at Sendil Kumar N. And I'm basically from southern part of India, Tamil Nadu. Anybody have been to India before here? A few hands. Great. And I'm currently living in Netherlands, and I'm a senior software engineer at Uber. Anybody knows about Uber? Okay, great. And I'm passionate about open source. I've been doing a lot of open source recently, and the main reason for me to do open source is like to learn things, and it provides me an opportunity to learn and understand how the industry works and what are the things that we need to take care of. And I'm a team member at JHipster. How many of you have used JHipster before? Okay, few hands, great. Hope you like it. And how many of you are Java developers? A few. .NET? Majority? Great. Okay. And currently I'm working on JHipster, which is Kotlin-based microservices as well as application generator. And Kotlin users? Wants to move to Kotlin? Okay, you? Great. Okay. So what we're going to do today, we will see what Kubernetes is all about, and it will be like a 101 or 102 kind of session. We go a little bit deeper into the architecture of Kubernetes, and then we see how JHipster helps you to generate a microservice. And then we will see a little bit about Istio, how Istio works, and what is the problem that Istio is addressing. And finally, we will see how you can use all those three concepts, JHipster, Istio, microservices, and Kubernetes together and deploy an application into cloud. And let's see how it goes. So Docker, how many of you use Docker? Yeah, quite a few. Great. What does Docker helps you to do? It creates a self-contained image, right? It gives that portability to your application. So you don't need to worry about the operating system or anything. You just need to worry about how it works inside those containers. That's what Docker is all about. But what did Docker didn't do? Any answers? What did Docker didn't do? Where it didn't help you? It didn't help you to manage your infrastructure, right? Docker has no capacity to manage the infrastructure in which everything you're running. And it also doesn't help you to decide when and how you can start your application. You can say Docker, start a process, run the container. That's it. That's what it can do. But it cannot manage the process. You cannot have something that kind of helps you to manage that process. So that is not there. On the other hand, Kubernetes comes into the picture, and Kubernetes, I see it as a decoupled infrastructure. That's it. Like it kind of decoupled the infrastructure part completely out of your architecture. You don't need to worry about it. What Kubernetes says is like, give me a piece of land, and I will decide how to run things inside. And I will decide how to form my containers or nodes inside, and I will decide how to run your application. You need not worry about it. So it kind of decoupled the entire infrastructure away, the entire hard part away. That's how I see it. And again, Kubernetes is an open source system. It kind of helps you to automate deployment. It helps you to scale your application up, down, horizontal, vertical, in whatever way you put it. But the most important thing for me is like it helps you to manage the lifetime of an application. You can put hooks when you start an application, when you destroy an application. You can do all sort of things inside a Kubernetes. You can tell Kubernetes to do these things for you, which is something very, very good. And it also helps you to restart your containers if it fails. In Docker, you don't have that capacity, but Kubernetes adds that capacity to your application. So Kubernetes makes it easy and simple, right? How many of you agree with that? A few? Okay. Yes, it does make it easy and simple, but inside Kubernetes, it's not that simple. Anybody have looked into the code of Kubernetes? One, did you like it? No? Did you understand it? Yeah, it's very complicated. Like even you spend hours and hours debugging what's happening inside, it's very complicated because the options that Kubernetes is supporting is so massive, and we often get lost for developers when we start learning about Kubernetes. We often get lost. So how Kubernetes works? Anybody? Anybody have read about this thing, how Kubernetes works before? A little bit. Kubernetes architecture? Nobody? You people all said that you were working with Kubernetes, right? Great. So Kubernetes works on a cluster mode. That's it. Like all this, just like any other application that we're doing now, it works on a cluster mode. It has a master node and server nodes. So you have a Kubernetes master and a multiple nodes, and each of those nodes have something running inside it that kind of helps you to deploy or provide a runtime for your application. That's how Kubernetes works. So we'll see what happens when you do something with Kubernetes. So consider this blue box as you, and you go ahead and write an YAML file. How many of you enjoy that process? A few? Nobody? Oh, one. Wow. You need to stop outside. So it creates an YAML file. In the YAML file, you just say what you want to deploy, how many replicas you want to deploy, and where I have to go and fetch that container. That's the thing that you're going to say. And once you've said that, you go ahead and run this command, kubectl apply -up, which is file, and with the file name. And what it does is like, it goes and talks with the API server that lives inside Kubernetes. And then it says like, okay, go ahead and apply this particular file. So it takes all the byte contents of this file, validates the file. Once it validates the file, it sends that file to the controller. And controller is the one which controls this entire thing, as the name indicates. And it also goes ahead and stores the information into etcd. So any of you, what is etcd? Sorry? What is it? Yeah, it's a kind of a database. It's a key value store. So Kubernetes itself is stateful. Understand that. Kubernetes itself is stateful. It has a database attached to it. And this etcd is responsible for replicating things. When a Kubernetes node itself fails over, this etcd is responsible for sending the information to multiple etcds or multiple in the cluster of Kubernetes. And from that, it picks up all the details and restarts your application. Once it is done, it goes ahead and adds this entire thing into the queue inside a scheduler. So the very first time when I say scheduler, it means it has a queue attached to it. So here you have a queue attached to it. It puts that information inside that queue. So this entire chunk of green things that you're seeing is called as control plane in Kubernetes, or the brain of Kubernetes. So this is where all the work of how Kubernetes should work happens. On the other hand, once the scheduler gets this information from the queue, it checks out what are the nodes that are available. There are a certain set of worker nodes. You can consider this as separate VMs or a VM or partition VM or something like that. But Kubernetes decides how to do this thing. So you have the separate set of nodes, and each of this node has a kubelet attached to it. And the job of kubelet is to just respond the information that a scheduler is giving to it. So scheduler says, okay, go and start the deployment. That's what I need to have. So it goes ahead and starts a deployment on a particular worker node, and it just takes which worker node has high capacity that is not occupied, and it puts that container inside that node. That's it. That's just what is happening inside. And worker node, if you drill a little bit deeper into that worker node, it has a kubelet and a kubeproxy. Kubeproxy is the one that proxies into the actual machines and does all sort of things. So that is what this kubeproxy is all about. So it handles the networking. That's the main thing. And Kubernetes actually is like a running state of your application. That's what Kubernetes is all about. At any point of time, take the YAML files that you apply to Kubernetes, you go ahead and see it. It's a running proof of your application. It says like desired state of the application. So that's it for Kubernetes. And for all the people who are using microservices, why do you move to microservice? What is the reason behind it? Come on, answers. 1 word, 2 word. Why do you move to microservices? Isolation. Too many people on the same repository. Yeah, that's also. Next. Scale. What is the other one? Yes and no, but it kind of, yeah. That depends on the architecture that you're doing. It's also one of the things. Yeah. There were some answers. Okay, so microservices, it actually gives you more freedom to react. Like for example, you have a monolith application, you want to add in a new feature, you end up thinking, how do you fit this entire thing into this particular picture. That's the one problem that we have to address when you're dealing with monoliths. But in case of microservices, you have more freedom to react. You can add a lot of things inside. You can spin out a new service as such as an independent service. Isolation is a key principle here. And it also makes you to respond faster. And technology heterogeneity, which is like you can have multiple technologies. You can make a choice of technologies that you want to run based on this solution that you're going to give. And one of the main things for me is like the fault isolation that microservices give, the resiliency that microservices talks about. Like in Monolith, if a problem occurs inside your application, everything runs inside application, your entire application will have an impact. But in terms of microservices, you can isolate that particular service away, throw that thing away, and then work with the rest of the services. And your application should still work. If it's not working, then you have not done microservices correctly. And another important aspect is granular scaling, which was touched upon. So monoliths versus microservices. There are a lot of drawbacks in both the cases, and you have to choose the one which suits based on the application or the architecture that you're choosing. And the main problem that I see is like in monolith, whatever the problems, or 90% of the problem that you're going to see is actually inside your application. The code that you have written has that problem, and you can go ahead and fix that thing. But in case of microservices, most of the problems will be from the networking, because networking is flaky. We don't have 100% correct networking everywhere. So this is flaky, highly flaky thing in which you have to live on, which is also difficult. And another thing, like whenever you see some people writing a new service, and then like you have 3 or 4 services that are created, and you go ahead and see like there are common chunks of code that will be present across those services. You cannot completely eliminate this thing. And I'm very much interested in dry, don't repeat yourself. But in case of microservices, at some point of time, you might end up in having a chunk of functionality that is written across multiple services with the same code. But you cannot actually eliminate that completely. You have to live with it. But one suggestion that I can give you is like, if you're writing a microservice, don't repeat yourself inside that microservice, and avoid worrying too much about how you can make a functionality that is available across microservice. So that is one thing that you have to decide. But for me, it's very hard to live it because I don't want to repeat myself in different sections of code with the same code. So that is the other disadvantage that I see here. So let's move back to the microservice with JHipster. So what is JHipster? It is a simple application generator. We do have a .NET backend, Kotlin backend, and a Java backend. And we also give you an option to choose between multiple front ends, React, Vue.js, and Angular. So you can choose any of the front end, and we also rely heavily on Spring-based framework. So the microservices that we are generating is API Gateway or BFF pattern. Anybody, what is BFF pattern? Ever heard about it? Yeah, backend for front end. So why did we choose this pattern? There are a gazillion of ways in which you can do microservices. But why did we choose this pattern? It's mainly because when we talked with all the people across the industry, and also to the main contributors, and also from bigger companies, all of them came out with this one idea. Like 80% of them said, like, this is the one that we use more commonly. And this actually scales pretty well. And if you're starting a new application, if you want to migrate your application, if you're doing it this way, it's much more easier. So that is the crux of why we chose this path. And how does a JHipster app looks like? It has a Java, Kotlin, or a .NET-based backend. And then you can choose between Angular and React. Vue is the newly added option. You can also choose that. And you have an user authorization and authentication service, which is UAA, which runs inside your application. And since we rely heavily on open source tools, and we also an open source project, which means we use a lot of open source tools, and one of them is Zool. Anybody here heard about Zool? Yeah, a little bit. Yeah, it's a kind of a proxying engine from Netflix that helps you to proxy all the requests from one location to the other location. So that's the main reason why we choose BFF. And in BFF, Zool helps you to do proxying all those services. And of course, you may or may not have a database attached to it. And we do have support for all the databases, all the major databases, you can say, SQL and NoSQL. So we put all those things together into a single application. That was fast. Okay, let's do it again. So we put all these things inside a single application, and we call that application as a microservices gateway. This is the gateway. This is through which your users will connect to your application, which means you have unified interface, and also you will end up in having a single way in which you can access all the APIs that you have. So this is one of the things that you have to make sure when you're going to BFF, there will be a single entry point for all the APIs to access. And service registry. When you talk about microservices, you have to talk about service registries, right? And for service registries, we have two options. And third one is Istio, which we will see later. That's why I'm added this here. But the two options are JHipster registry and console. And JHipster registry is a custom build, and it is having a principle of availability over consistency. So at any point of time, it makes sure that the particular instance is available before telling you that the service is available. So that is availability. On the other hand, console gives consistency over availability. So console is a product from HashiCorp. Anybody used console here before? Yeah. So console is from HashiCorp. That kind of helps you to register your services and also helps you to discover the services. So when a service A has to talk with service B, microservices don't know the context of how to reach service B. All it does is goes to the service registry and then gets the information about service B and then connects to the service B. And that's what the service registries are useful. And JHipster registry is built on top of Netflix OSS model. And console is very good for multi-node as well as language agnostic. Console is language agnostic. It's kind of lightweight, but the difference is console runs on all your microservices, which means you have to add console to each and every microservice that you have. On the other hand, JHipster registry runs at a centralized location. That's a major difference. And in microservices, it's very hard to debug the problems. And for debugging the problems, we have consoles. We have something called JHipster console, which is built on top of ELK. You can also attach a normal ELK stack to the application generated, and it kind of helps you to find out the bottlenecks where you have the problem and how you can solve those things. Great, so you have this microservices gateway, and your application connects to it. Then you have a set of services. These services are what we call as microservices, and these services are individual applications, and it will have a database, may or may not have a database attached to it, but it will not have an UI. And we have a console or service registry, and finally we have a console where we can go and see the bottlenecks that we have in the application. So this is how a JHipster generated app will look like, a JHipster generated microservices app will look like. Great. So what we are going to generate is a simple store gateway, which has three services attached to it: notification, product, and invoice. The store gateway and product and invoice, all of them have a SQL-based database. And notification will have a NoSQL-based database. That's it. So that's what we want to generate. And we'll see how to add entities and how JHipster produces an application. Let's go ahead and see. So is this thing visible for everybody? Or do I want to zoom? This is okay now? Yeah, great. So yeah, so what we have here is like, we call it as JDL, which is JHipster domain language, which kind of helps you to bootstrap your application in a much more concise and faster way. So what we are generating, a 4 application. So these are the 4 applications that I've listed. The first application has some set of configuration, which is a store. And it says like the application type is a gateway, which is microservices gateway. And this is normal Java things like adding a package name and things like that. And you can go ahead and specify whether you want to have a service discovery. If you want to have it, whether you can select between JHipster registry and the console that we have discussed. What kind of authentication? You can use JWT, you can have OAuth authentication and things like that. What kind of database that you want to use, cache, what is the build tool that you want to use, what is the client framework, and inside client framework, what are the things that you want to use. One thing that we are also doing is like, we not only generate an application and just leave as it is, we also generate tests for that. And the code that we are generating is having more than 86% of test coverage, which means you don't need to worry about all those boilerplate things that you have to add tests. That's one of the important things. And similarly, you have another configuration for another application, which is for product. And the only difference here is a microservice. Instead of gateway, we define it as a microservice. And I think this is for notification. Yeah. So this is the notification, and the database we are defining MongoDB. That's basically it. With this, you can create an application. And of course, any application, it doesn't matter. It needs to have an entity attached to it. So we also have a list of entities that are attached to it. For example, here you can say first name and all those things. You can just define this, as a JPA, normal JPA, and it kind of generates all the bootstrap code that you need to configure this entire thing. And one of the most important thing you can see is like, you can add an entity to a particular application like this. So you can define all your entities inside one single area, and then you can split those entities based on the applications that you have. And anybody can reason why do we have this entity star at this place? No? Because as I said, gateway is a single endpoint for all your services to have an user interface, which means like this service should know about all the entities that you have inside your application. So it kind of we put entity star, which means all the entities will have an UI generated inside this gateway. That's the main reason why we do it. And once you have done this, you just have to write one command, which is JHipster import JDL. And if you want to experience that, I also have a workshop on Sunday. If anybody reminds here on Sunday, you can come over there to the workshop. For time and all those things, I've created the application already. This is entirely a new set of application. And you have the store. So this is analogous to the store that we have created, which is a normal Java application with main, all those things. We also have the entire Docker files generated for you, which means you can run your application from day one on a Docker. And we also have all those things that is automatically generated. It's a Spring Boot based app. Anybody heard about Jib? Any Java developers have heard about Jib? The Jib is a faster way of bootstrapping your Docker. Jib is called as Java Interface Builder. It's from Google. It kind of helps you to bootstrap your Docker images at record speed. So that's what this entire thing. And then you have a normal web app, which is entirely written in TypeScript. And also it has React, so it's a React TypeScript thing. And finally, this is store, and then you have this product, and then notification and invoice. So everything is built for you. Everything is made. Your application will be starting and running, and it will also have all those entities attached to it. So let's switch back to the slides. So when your application at this size, it's fine, right? When you have more microservices added to it, now it's kind of manageable, but you can live with it. But what will happen when you go to scale? Anybody at this scale now? Anybody wants to go to scale now? Think before you're doing it. It becomes very harder to control your microservices. It's the reality, because you have multiple different services running across. It really becomes very, very harder to control these services. And it also makes it very harder to manage your services. You cannot manage each and particular service. You cannot find out where the problem lies. If one of the services fail, it's very difficult for you to understand which service is failing, because you don't have mechanisms to understand it. We generally lived in a world of monoliths so far. And moving to microservices, this is the biggest problem that we have. And finally, it's very hard to secure. You have thousands of services attached to it. How are you going to secure it? What are the correlation IDs that you're going to pass through it? How do you identify the request that is coming as genuine? These are the things that's very difficult to answer and very problematic to answer. On the other hand, you have the services. For example, you have service A, B, and C. You end up in seeing something like this. You have a logging, you have a monitoring, have a networking. These are the common chunks of things that you put inside your application, and it remains on all those applications, right? So when you do like, okay, I'm moving from logger service A to logger service B, I just have to update one single library in my entire application. I have to go through all the services, update this thing, deploy this thing, and make sure that this thing works, which is the most hardest part that we have as a developers. Everybody agree with me? Yeah? So what we can do is like plug this common services out and deploy them as a separate services and use that. That's great, right? You have some mechanism to do something like this. Your code will be more modular. It will be more easier for you to do this. But what if I say you that you can do all these things without even touching your code? Anybody agree with me? That's what Istio is. So that is what Istio is. So the Istio tries to do this plucks all these common chunks in your code that you basically end up in having in each and every microservices, takes all those things away and put it in a separate stuff and says like, okay, you give all the requests to me, I take care of everything in your entire set of microservices. I will give you security, I will give you control, I will connect your services, I will do the load balancing and all those things. I will do everything for you. You need not worry about it. So before we deep dive into what Istio is and how the components of Istio looks like, anybody here to take an answer for service mesh? Am I asking a lot of questions? Yes, please. Yeah, that's Istio, but what is a service mesh? In plain English, you can, if you want. Kind of, but that again touches the concept of Istio. You want to take it? Same? Okay. So service mesh is nothing but, in a simple English term, it's a set of interconnected services. That's it. So you have a list of services, and you have interconnections between them. That's a mesh, and that's a service mesh, since they are services. So without any changes in your service, Istio tries to achieve this entire thing. What are those? These are the 4 things that Istio tries to do it. One is control. It helps you to control your services. The other one is connect. It tries to do the service discovery part all by itself. And it also uses secure. It authenticates and authorizes the request that is happening between those services. And finally, it gives you a tool to observe what are the things that is happening inside. But how does Istio do it? Let's go ahead and see it. So Sidecar is one of the main mechanisms which Istio does it. So you have an application that is running inside a pod. Before that, what's a pod in Kubernetes? The Kubernetes people. What's a pod in Kubernetes? Yep, one or more containers inside your application. Inside that, it's called as pod. And we actually use that one or more word here. So instead of having just your application inside that pod, what we do is like we kind of expand this pod and put a proxy inside it. So all the services, all the requests that you're giving to that service will actually go through this proxy. That's it. And that's how, that is what we call it a sidecar. And the proxy that we are using is called as Envoy proxy. So Envoy proxy is a lightweight C++ protocol. So you need to understand when you put a proxy inside your Istio, you're gonna have a simple latency attached to your services. And in microservices world, we are trying to eliminate a latency. But when you go to Istio, you're adding a little bit of more latency to your services. You have to understand that particular part. Adding Istio doesn't speed up your application. It actually slows it down by a factor of nanosecond or millisecond. And you have to think before adding this thing. So that is what it does. And once you have this running in a pod, what you can do is like, so Istio actually talks with the pod, that the proxy, rather than talking with your application. And that's the main reason why Istio in Istio, you need not do anything in your application. You need not change anything in your application. The main reason, it just talks to the proxy. It doesn't talk to your application. And proxy handles all the other things. So you have something called Mixer, and Mixer is responsible for policy control and telemetry collection. So what is telemetry? Telemetry is like collecting the logs, the debug messages, and all those things. So from Mixer, so Mixer is the one that collects all the telemetry that goes inside the app via proxy. So you have a single endpoint in which you can query and get all the telemetry about your particular service. On the other hand, you can also apply policies on the go. What do you mean by policies here? You can say like service A can connect to service B. You want to scale up service B. Or you want just request that is coming from a mobile phone goes to service B. So you can do this kind of finer configuration using Mixer. And of course, just like Kubernetes, you also have a control plane here. So what does a control plane look like? You have a pilot, you have a galley, and you have a citadel. So these are the things that lives inside the control plane. The pilot is responsible for piloting or service discovering your entire application. And galley, anybody know what galley is? No? So galley is a trolley. If you have ever been to airplane, galley is a trolley that crews will take the food with them. So that is a galley. So similar concept. Galley is something that validates the services, that the configurations that you give it to Istio, and it pushes this configuration to each and every service that you have it, which means to the proxy that we're talking about. And we have a central node which handles authentication, which we call it a citadel. So this entire thing is this entire segment is a data plane where your data lies, and this entire segment is a control plane where your entire control lies. So this is what the 4 functionalities that we have defined. Citadel helps you to secure your application, Galley to connect, Pilot to control, and Observe for Mixer. So what does the JHipster Kubernetes does here? So how does JHipster helps you to do with the Kubernetes and Istio? Let's go back. So this is what we are going to do, how to generate a Kubernetes plus Istio configuration, and how we can run this entire thing on a G Cloud. Okay, let me create a folder. Let me call it as Kubernetes, new, because I have another folder with Kubernetes. Yeah, so what I can do here is, I can just go ahead and, okay, let me use the correct node version, because this is where, oh, okay, great. So what I can do is like run JHipster Kubernetes. So what it does is like it first checks whether you have Docker installed. So once it verifies that you have Docker installed, it goes ahead and asks you which kind of application that you want to deploy. You can go ahead and say like Monolith or microservice. In our case, we're doing microservice. We'll just use this microservice application. And it asks in which location that your microservices were there. So I go ahead and give it. It finds out all the microservices that I have, and I can choose them. Once I've choose them, it goes ahead and asks you whether you want to set up a monitoring for your application. So we have this JHipster console, which is based on ELK, or you can just go with plain Prometheus. I'll say no here, because we are just going to use Istio and see how Istio works. So I'll just use no here. And it also finds out that you have a database attached to it, and that database has an option of clustering the databases. If you're doing it manually, it takes a lot of time for you to cluster use a cluster database, setting it up right, and then finding how it works and things like that. But with JHipster, we also provide an option to do this thing right from the beginning. You can cluster this database. Since notification is using a MongoDB, we can use a cluster database here. I'm not going to use it now. And finally, it asks you what namespace of Kubernetes. I'd like to define a namespace as a folder in a Kubernetes in your desktop application. It's where you put all those things that you don't want, or all those things that you want to run inside one particular folder. For now, let's just select the default one. And it asks you Docker repository name, because it has to push that image into your Docker repository. So I put my name over there. And since G-Cloud also has its own variation of Docker push, and also if you have a custom registry, you need to have a Docker push command all by yourself. You can have a different command, but we are just going to use Docker, so I'm saying Docker push. And finally, this one simple question decides how you want to do a service discovery. And this is like, do you want to enable an Istio? So you can choose between yes and no. We are going to use Istio, of course, yes. And once you've done, it checks like, what is an endpoint in which you're going to do all those things? Give me an endpoint in which I can access this entire thing. So what I am going to do is like I'm just going to use the default one that is listed here. And once I've done this, you can see here, it kind of generates a list of files for me, all those files that is required, segregated by the application. And once it is done, it also gives you a few commands like, go ahead and Docker push all those images, tag those images, and push those images. And if you don't have if you don't have an image available, this is how you can generate an image, because I've used Gradle. So Gradle Bujar to generate an image, and with JB build, you can just push that image, specify a name to that image that pushes everything to the container. Once you've done all those things, what you're going to do is like just run this command, which kind of does everything for you. So let's go ahead and see the code that is generated. This is not that. Yep. So you have this kubectl file, which kind of says like, okay, so this is this entire thing. I'm going to say this is the entire segment in which we are saying all the spots that you're going to run inside that particular namespace will have Istio injected automatically, unless otherwise I specify like don't inject anything. So all the ports, you see that proxy thing running, that is enabled by this single line. It says like inject Istio wherever you find a pod is getting created or running. It will not affect the existing pods, but when your existing pod is getting recreated, it will have a proxy attached to it. And then apply a set of folders for invoice, notifications, product, and store. For example, let's go and check the store. So what you have is a deployment. Deployment is where you specify the base image of your application. So I'm saying like, wait till the DB is up. When you initialize a container, wait till the DB is up. Once the DB is up, use this particular image that I'm going to create, and from this particular Docker repository. And with this set of environment variables, with this request limit, I'm saying like, you can use 512 megs of CPU, some memory, and you can use 500 megs of CPU and things like that. And this is a port in which you're going to run. And readiness probe and liveness probe is something very, very important that you have to add to your application. Liveness probe decides whether your application is live or not, and readiness probe decides your application is ready or not. So these two things are very important for your application, because you have an endpoint in which Kubernetes goes and checks whether a particular application is running. If the application is running, it says, okay, it's running, it's healthy. But on the other hand, if you want to restart your application when it's not running, this is a particular place that you want to check, go and check whether your application is running. And this decides how the service discoveries connect to your application. So this is very important for your application. So this is where deployment comes in. And we also follow the general best practices in the Kubernetes world, like segregate your YAML files for separate functionalities. And then finally, you have a gateway. A gateway is the one through which your application goes and connects. This gateway is not microservice gateway that we're talking about, but this gateway is for Istio to understand. So this is Istio's gateway. And here it gives you an IP. So this is where you can go and connect for your application. And also it creates an HTTP endpoint, HTTP 2 endpoint, and all those things. It also it says like, okay, so whatever that comes with the prefix of /service/invoice has to go to that invoice host. Or notification should go to the notification. And if it's just single slash, it goes to store. So this is where you actually define how your application should work, how you're going to match those DNS and sub DNSs to the applications. So that is one of the major things that it does. And MySQL, it's again the same MySQL database, how you're going to start it. And it's very good thing to see here is like the database that you're going to use need not have Istio attached to it. It may have, but it's not needed most of the times. So what you can say is like, okay, just disable Istio for this particular functionality. So your MySQL database will not pop up in your application graph or things like that. And what do you have it here? So this is a service. And finally, you have a virtual service. And this is a service that is created on top of gateway that we have defined. So you have your application, which is a deployment running. And then on top of it, you have a service. And on top of that, you have a Istio service. And on top of all this, you have this virtual service. Virtual service is a particular endpoint which decides how your application should be connected. For example, here you can say like, okay, go to version 1 for 100% of things. And I can also go ahead and say, go to version 2 for 50%, go to version 1 for 50%. And those are the things that you can configure on a virtual service. So if you see it clearly, virtual service is the one that defines a weightage of how your application should be accessed. On the other hand, gateway defines where application should go and look for to if you accessed a particular URL. So that's what the main difference. So yeah, so we have done this thing. So once you have done this, all you have to do is like kubectl apply. And Istio comes with its own set of things. We have Grafana, Kiali, and Zipkin. Grafana for the dashboard, how your application works. And Kiali to observe things. And Zipkin is just to make sure the traceability that you can have inside your application. Remember, we haven't selected anything. Like we haven't used JHipster console or a Prometheus. If you have added this, then those will also be deployed here. But we haven't done anything. So what you have to do is like I've created a cluster inside a Kubernetes, inside GKE. So I have a running Kubernetes cluster here on this particular machine. And I've already deployed everything because I know conference Wi-Fi. I've experienced that. So I've deployed everything. So you can go ahead and check all the workloads that it has. So what I did is like once I created a Kubernetes cluster, I installed Istio on top of it. So you have list of Istio. This is latest 1.3.5 Istio. I've added all those Istio inside it, Istio related stuff. And Istio adds ton of different functionalities inside your application. It has something like the pilot that we have seen, but it also has policy, sidecar injector, and all those services, which are small services that adds to it. But the major chunk of service is pilot, and make sure that you have correct limits when you're running on your local repository, because pilot tend to hog up your memory like anything, and it kind of destroys this entire thing, entire architecture. Because once I was doing a demo, right in the demo, I started my Istio on my local Kubernetes inside my Mac, and everything froze. And I have to reboot my entire machine, stop Kubernetes, kill that process, and then go for it. So make sure that you have a hard limit for the Istio pilot, because it tries to hog up on your memory. And I've deployed all those things here. You have the Grafana, I have Invoice, which is a service with the MySQL, Kiali, notification, and all those things that we have seen. It has been deployed with just one single command. And this is how the application will look like. So let's go and sign in. So it has user authentication built inside it. So you have an admin UI, which has user management. These are the list of users that you have. And you can have the metrics of your application. And you can also check the health of the application, which one is running. You can modify the logs. You can change the configurations and all those things. So this is the admin side of view. And for users, you can have this entry point where you can go ahead and create a new customer, add a new customer with all those information, click on a save. It also has this validations and all those things. So it kind of helps you to do this entire thing together. You can add a product, you can add a notification, and this is where you design your entire application. This entire thing will be designed over here. And it also has its own like translation stuff. I think there are like 26 to 30 languages that we support. So you can also have an I18N built in. So that is also available for you at the very first stage. And the most important thing for me is like this dashboard that we have it here, which is generated by Grafana. So this dashboard at this particular endpoint, it also checks like what are the things that you have, how you can select, what are the load places, and all those things. You can go ahead and configure this Grafana dashboard if you want. So there is like huge set of Istio related dashboards that is automatically available. But if you want for your application, you can just go ahead and add those application related dashboards. And finally, this is a new thing from Kubernetes world. This is called as Kiali, which is help you to observe things. And Zoom doesn't work here. Let's check how it works here. No. Okay. It doesn't work correctly here. Okay. So this gives a picture of how your application looks like. So you have this gateway, which connects to your store, which is your microservice gateway application. And it connects via HTTP. And then it connects to a MySQL. Come on, okay, which connects with TCP, and on the TCP other hand, it has a MySQL again here. So what's the difference between this triangle and the square is like the triangle is a service which is running on top of your service, on top of your database, and the square is the actual pod that is running inside there. So this is how it looks like. So again, you have the set for invoice, notification, and product, and all those things. So it also gives a complete overview of how your systems looks like. So for example, here, if you're seeing my application is pretty small, it just have 8 things running, but Istio is much bigger. It has 12 things running inside. So beware of Istio. And if you want to have a lighter version, you can have things like Linkerd, which is a very light version of Istio, but it has reduced functionalities. But if you take a look, Istio adds its own Grafana. And Istio also adds Agar, Kiali, and Prometheus. We have not used Prometheus, but Istio adds it. So if you want, you can uninstall this particular Prometheus thing, but Istio bundles with this list of functionalities that we have defined here. And it also specifies the health of the function, and you can also go ahead and see all the services, and that's a major thing. So here, this is a particular endpoint in which you can say how this entire thing works. And here you can see like MySQL, we have said like we don't have a sidecar attached to it. So it also specifies that it is missing sidecar and things like that. And that's the basic thing that happens here. And this is the application that is generated completely. But it's a matter of like doing an npm install and downloading all your dependencies. I'm not relying on the network, which will hog on the network, and everybody will face a service down here. So that's the main reason why I haven't generated an application, but we have a complete workshop, and if you want, you can just come over there and see that. So we have done a lot of Kubernetes and Istio. There are like a lot of industry leaders who come to the particular project and help us to generate Kubernetes files. And we have learned a lot of things. And it's very important for me because I joined open source just to learn things. And this is very important for me. So I'm going to propagate this thing. It's like the best practices that you can do when you're doing Kubernetes. The first major thing is like single responsibility. Yes, it still applies to Kubernetes. Always have smaller YAML files and try to split those files and try to put those semicolons correctly. Sorry, colons correctly. And also try to find out, create a smaller image sizes. Always have to have a smaller image size. Alpine images really helps you to do it. And it also helps you to boot your application faster because whatever application that you're going to generate, whatever application that you're going to create, it actually has to boot up every now and then. It has to shut down and restart it again. So always try to have that thing, have a smaller image. Try to reduce your image sizes smaller, which kind of helps you out. So anybody can tell me what is healthy zombie problem in the Docker world? Sorry? Yes, you can say that too. Yep, you can say that too. But in a Docker world, it's like you have multiple processes running. And Docker doesn't have any capacity of understanding which process is alive and which process is dead. If one of the processes inside the container is running, then Docker says like, I'm healthy, you need not worry about me. But all the other processes might die. Your application might have an outage. And that's what we call it as healthy zombie problem because we have zombie threats inside. So always try to think of having a single process inside a container, not a pod, but inside a container. Always think of having single process. If you have multiple processes attached to it, try to find out a way in which you can check both the processes running all the time. Because we don't have a perfect mechanism in Docker to do that. And always follow a red pattern when you're designing your services. Check out the requests, check out the number of errors, check out the duration that it takes. Always check that pattern. So whenever you design a service, think of those 3 words and evaluate the service that you created as having this thing correctly. And for resources, which I mean like the databases and all those things that you are going to run, have this use pattern, which means like how much it is utilized, how much saturated your resources are, and how many errors that you're going to have inside, and design your resources on top of it. Think about request and limit. We have already shown you how the request and limit looks like in the Kubernetes file. So think about it. You have to have request and limits in your application because that kind of helps you to eliminate hogging up the entire memory or your services not scaling really well. And those things will be handled if you have a very good request and limit. And clean up the resources, which is thing, and monitor and tune your services. That's the basic thing that you're going to do. Yeah. So for questions, for Slido. Okay, it's not connected to internet. Or it's not working. Okay, it's loading. Okay, thank you. Okay, it's loading, I'll answer this. So what are the single point of failures components in Kubernetes standard infrastructure? Great, yeah, so if I understand you correctly, you're asking about what are the components that have a failure rate, higher failure rate. I think it's mostly the services that doesn't have request and limit attached to it. It's always the problem that we face, but people coming and telling like Elasticsearch is hanging. I cannot access Elasticsearch. You have given an option to Elasticsearch. The Kubernetes is running correctly. My services is responding correctly. Kubernetes doesn't tell about the services, but we don't know how this entire thing works. I mean, we don't know how the services actually, the service is actually not responding. This is a common thing that we're getting. And the major reason behind that is like you haven't set your request and limit correctly. So Elasticsearch, when it boots up, it has to have the requested amount of memory, and you have to give a little bit more than the requested amount of memory. And also you have to continuously monitor whether it reaches that top level. And if it reaches the top level, then you have to think about how you can scale this entire thing. And those are the things that is very important to handle. So it is very important for you to handle request and limit inside a container. If you have request and limit correctly scheduled or correctly controlled inside a container, I guess most of your problems with respect to this thing will go away. Oh, the question went off. Okay. What tools to use for local Kubernetes development? Who? Okay. So Docker for Mac is really good for doing local development, but I would argue that if you have more than 16 gigs of memory, then go for Docker for Mac, or else rely on, if you're having Linux, micro K8 is really awesome. But Docker for Mac, for me, it's like it hogs up your memory like anything, and also attached to your power source if you're traveling, and also trying Docker for Mac, it's good luck with you. Have some other books to read. But this thing is, if you're having connected to an internet and also have a power source and have more than 60 gigs of memory, Docker for Mac is really good. And other thing, micro K8 is really good. And if you're any OpenShift fans here, you can also try OpenShift, but the security model is kind of different, but you can also use the OpenShift locally. What's the next one? Can you have a separate repository per microservice when generating code using JHipster? Of course, that's one other thing that we are also forcing or creating the application as a chunk of different folders, which means like we force you to think of them as a separate services as a whole. So all those things end up in a different repository. If you want, you can push all those things together and say it is a monorepo. But on the other hand, push them separately. It's a simple folder that has its own things attached to it. For example, so yeah, I'm sorry. So yeah, so everything that you have here is a separate folder, and it also has its own git config and git attributes and all those things attached to it, which means we consider them as a separate repository. But we have commonly seen people like pushing all those things together and call it as a monorepo, which is also fine at the end of the day. Gits are now tuned to have a monorepo, but I would suggest have them as a separate repository that eliminates redundancy and helps you to decide how your services should evolve. Okay, that's it. We have the questions here. And do we have any more questions? Okay. Does this fork for HTTP only or any traffic? What is the use of RabbitMQ? What if we use RabbitMQ? Of course, you can use RabbitMQ or any messaging system like Kafka and things like that. And it doesn't only work on HTTP. It goes to TCP, it goes to UDP, and it goes to all the levels of traffic, like whatever the traffic protocol that you can define. It has all those things added to it. So which means like Istio also helps you there. Kubernetes also does that. So as you have seen, like you have TCP between MySQL database and your application. So it kind of, you can tweak all those connections if you have an Istio layer attached to it or a Kubernetes layer attached to it. It kind of helps you to configure that too. So I think that's a question. Any other questions from the crowd? Yes?
Are there any less opinionated tools
For?
Managing your microservice infrastructure?
I mean, okay, so less opinionated, I think it scales from this range to that range. Very less opinionated is the manual things that you have to do for your tools. And you have something like Linkerd which lives in the middle, which means like you have to add extra components for each of the functionalities that you want to add in. That is the other thing. And the final thing is like you have something like Istio and Kubernetes that kind of helps you to do all those things together, but in the way that they are suggesting to do it. So this is a spectrum in which we live in. So it's up to you to take, or up to the team that you're working with to take up this risk of selecting which part of the tooling that you want to do with.